In this experiment, we're going to set up a steady state heat flow condition. We're going to measure the temperature with a thermocouple. That's this device. We've used it before. We're going to use the circuit panel and easel. We use a digital multimeter. We've got a switch that we're going to connect to our heating unit. And this has a resistor on it that generates heat. And we've got a heat transfer accessory, which is basically an aluminum cylinder. And what you do is you connect the thermocouple here. You turn it, push it in here, and then use the Allen wrench and tighten it up so it's connected on the top and on the bottom with the other thermocouple. And then we're going to take this thermocouple and we're going to use the stopwatch, and you'll determine the heat flow rate and using the calculations that we have in this lab to determine what your heat flow rate is.
Going to be using delta T calculations. You're going to take the temperature of the bottom, subtract it from the temperature of the top, and this is going to be in your you got to convert these to from millivolts. So you'll come in here if you got 1.57 millivolts, that would be, come straight across here, that would be 20 plus 6, that'd be 26 degrees. If the thermocouple millivoltage is 3.5, that would be 50 degrees. So you take what your millivolts are here and you go across this way and you add whatever these numbers are right here. In trying to calculate the surface area, you're going to use this formula. Pi times the diameter square divided by 4. And that gives you the surface area of the device, the heating element that you're going to be measuring. And you got 3 of them. So you have 3 calculations here. This one right here is when you're going to calculate the heat flow rate. And you're going to take your volts times your amps. Yesterday that was in a separate calculation. And this comes from the front of your power source. And whatever the voltage is there, you're going to multiply it, push the button in and get the number of amps. That's your current flow. And you multiply this times this conversion factor, which converts it from watts, which is what you get when you multiply these two numbers together. So you go from watts to calories per second, and that's the correct unit for heat flow. And then you're going to take this formula and find your heat flow rate out of the conducting cylinders, and that's going to be in calories per second. So you're going to take the K, and that's a constant number, and these are your units. You're going to multiply it times the area. Where do we get that? That's from back up here. And you're going to multiply it times the change in temperature, and that's going to be in degrees Celsius. And you're going to divide that by the length of it, which is going to be this measurement right here. Which is going to be not across this way, but the distance from the top to the bottom.